Okay, we're going to start with section 2.2 here, and the beginning of the book basically goes over what you need to know in algebra to kind of succeed in this class. So we're going to start with the basics, and I'm just going to go through some concepts here, and then we'll try practicing some problems on the backside. So the first thing that comes up quite a bit is the distance formula. You do need to find the distance formula throughout this book, or you need to find the distance between 2 points in this book. So if I look at this formula here, it's basically the difference between the x values squared plus the difference between the y values squared, and take the square root of that entire thing. And so basically you're looking at if I have 2 points here, let's say I have a point here at, what is this, 6, 6, I believe. And let's say I have another point at 3, 1. So this would be the x of 1, this is going to be the x of 2, this will be the y sub 1, and this will be the y sub 2. And you basically want to find the distance between these 2 points right here. You want to find that distance. And so if you think about this, you can kind of break this down into a triangle where this is the difference between the y values and this is the difference between the x values. The difference between the x values is, of course, 3. The difference between the y values is 5. So we're looking at the square root of difference. What do we say? The difference between the x values is 3, so it's 3 squared, plus the difference between the y values, which is 5, so it's 5 squared, and you take the square root of that whole thing, so it's whatever the square root of 9 plus 25, or the square root of 34. And so, you know, if you think back to your geometry from past years, this is basically the Pythagorean Theorem, right? You got a squared plus b squared equals c squared, and you're basically solving for c here. Okay, so first thing you got to keep in mind is, as we go through the book, that the distance formula, if you forget it, it's the same thing as doing the Pythagorean Theorem, if you remember that from your past years. The one thing also to watch out for here is to make sure that you don't take the square root of two things that are added up squared here and get x sub 1 minus x sub 2 plus y sub 1 minus y sub 2. Okay, that is not the same thing. You can't just take the square root of it and get rid of these squares. The next formula here is the midpoint formula, and that's if you want to find the midpoint between 2 points. So if I go down here again and I wanted to find the midpoint between this point and this point, it would just be the average of the x's, comma the average of the y's. So we're looking for basically this point that's kind of in the middle there. So what we use to find that is you look at the average of the x's, add the x's together, divided by 2, comma the average of the y's, and that gives you the midpoint. The slope formula you should know from last year. If you don't remember this, it's basically the change in the y values divided by the change in the x values. I know some teachers will say rise divided by the run. So hopefully you remember that from last year. Slope-intercept formula is good old y equals mx plus b, where m is the slope, b is the y-intercept. Point slope form is the one that I actually use the most. It's y minus y sub 1 equals m times x minus x sub 1. Now, if you forget what this is, you can hopefully see that these formulas right here and here are exactly the same. Okay, if I divide both sides of the slope formula here by x sub 1 minus x sub 2, I get this formula right here, the point slope form. And as we go through the problems on the back side, I'll show you how to use point slope form. I usually use point slope form when I'm trying to find the equation of a line. General linear form is this guy right here. It's also in many books ax plus by equals c. And most often it's used when people are solving systems of equations, plural, and they want to get all the x's lined up, all the y's lined up, and all the constants lined up on the other side of the equal sign, and then you want to use elimination method where you add the two equations together to get rid of one of the variables. That's when you most frequently see general linear form or standard form. Vertical lines, so if I'm looking at the equation of a vertical line, let's say I have a vertical line like this, the equation of that would just be x equals wherever it crosses the x-intercept, the x-axis, so it'd be x equals -2. Horizontal line is going to be where, like this, going across this way, the horizontal line, that's just going to be y equals where it crosses the y-axis, y equals 3, right there. The slope of this thing is equal to 0. The slope of this thing has no slope. The last couple things here that hopefully you remember from previous years from last year is that parallel lines have the same slope. They just have different y-intercept, and perpendicular lines have opposite reciprocal slopes. So if I have a slope that's 2/3, the slope of the perpendicular line is going to be the opposite of that, which is negative, and then the reciprocal is when you flip it, so it's going to be 3/2. So the opposite of 3/2 is going to be the opposite reciprocal slope of 2/3. Okay, that's the information you need to remember, for at least for now, from last year. So I'm going to go ahead and jump to the back side and try some problems on the back side. Okay, here we are on the back side. What we're doing first is writing equations of lines. So equations of lines. And the main thing with an equation of line, if I have the slope and a point, I can always find the equation of a line. So if I have a point and a slope, I can always find the equation of a line. Of course, the simple way is to use the point slope form. So for this first one, if my slope is -2 and my x-intercept is 4, x-intercept being 4 means that my point is 4, 0. I can always plug it into point slope form. So point slope form is y minus y sub 1 equals m times x minus x sub 1, where this is my point right here, x sub 1 and y sub 1, and m is my slope. So if I'm taking this, it's going to be, my point is 4, 0, so y minus 0 equals m, which was -2, given, and x minus, and then 4 was the x value of my point. I can solve this thing if I want, or I can leave it. If it doesn't tell you specifically to put it in a specific format, you can leave it in whatever format you want. A lot of kids feel comfortable putting it into into slope-intercept form. So I would distribute the -2 here and here, so I get -2x plus 8, and that would be the equation there. Containing these 2 points, do I have a point? I have to always ask myself, do I have a point and a slope? I do have a point. I have 2 points, in fact. I can pick one of them. It doesn't really matter which one. You can use either. And I can find the slope. Slope is just going to be a change in the y values. So it'll be 5 minus 1 divided by the change in the x values. You have to go in the same direction. So if I start here with my 5, I need to start here with my x. So it's going to be 2 minus 7, or 4 over, what is that, -5. So my slope is going to be -4/5, and just pick one of the points. So it's just going to be y, pick the first point, y minus 5 equals -4/5, x minus, and then the 2 is my x value right there. And there's my answer. I can leave it in that form, again, if I don't specify. X-intercept is 9, y-intercept is -3. Again, I have 2 points here. I can choose either one of them. In particular, this point is going to be 9, 0. This one's going to be 0, -3. Find the slope of this thing. My slope is going to be 0 minus -3, or 3, divided by, it's going to be 9 minus 0, or 9, or positive 1/3 is my slope. Now I can recognize here that I actually have the y-intercept here. So if I wanted to, I can recognize that I have a slope and the y-intercept, and I can just use slope-intercept form. So it's just going to be y equals 1/3 x, and then my y-intercept is -3, so it's -3, like that, and I can just use that. Parallel to this line just means that's the same slope, so my slope must be 7, and containing the point -1, 5, so it's just going to be y minus 5 equals 7, that's my slope, x plus 1, I'm using point slope form here, and I'm done. It's pretty simple. Perpendicular to it just means that my slope is equal to the opposite reciprocal, or opposite of 1/7. And then I do exactly the same thing, just plug it into point slope form. Okay, next problem here, it says that a line has a slope of 3, so my slope is 3. One of the points is 2, -3, the other point is 5p. Two things you can do here. You can either plug it into point slope form, or I can plug it into the slope formula. Remember, they're identical. So let's just use the slope formula. M is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And let's just start plugging in here. So this is 3. I know that I can plug in. Let's just make this my x sub 1, y sub 1, and x sub 2, y sub 2 here. So it's going to be p minus -3, or plus 3, and then my x sub 2 here is 5 minus positive 2, and that's just equal to positive 3. I can solve this equation. This becomes 3 down at the bottom here, 3 over 1, cross multiply, so I get 9 is equal to p plus 3, and so p ends up being equal to 6, positive 6. Given the line, this line, find the coordinates of the x-intercept. If you remember graphing this thing, or finding x-intercepts, to find the x-intercept, remember the x-intercept is where it crosses the x-axis, like this. So the interesting thing about this is the y value is always going to be equal to 0. So what I can do is basically in the equation set my y equal to 0 and solve for x. So I get 2x equals 5, x is equal to 5 halves. That's my x-intercept, or 5 halves comma 0 is actually the coordinates of the x-intercept. For the y-intercept, just set the x equal to 0. So let's change our color here, set the x equal to 0. And so I get 7y equals 5, or y is equal to 5 over 7. And that'll be my y-intercept. To find the slope of the line, I can do one of two things. I can either solve this thing, the equation for y, put it into, in other words, put it into y equals mx plus b form by solving for y. And whatever my b is ends up, or sorry, whatever my m is ends up being the slope. If I wanted to find the y-intercept, I could do that by finding the b. And or the other thing I can do is I can take these 2 points which we just found, this guy, and just find the slope using those 2 points. Let's jump all the way down here, show the slope is the slope of the graph ax plus by equals c. So, like I mentioned in the previous problem, finding slope of this thing, basically if I solve for y, I should end up with y equals mx plus b form. So I want to put this whole thing equals y equals mx plus b form. And the way you do that is basically solve for y. So I can bring the b over to this side, bring in ax over to this side. So I get by equals the opposite of ax minus c. Divide everything by b, so divide every term in the equation by b. So I get y is equal to negative a over b times x minus c over b. And so here, hopefully you can see that my slope, because this is my m in the mx plus b, my slope is just going to be negative a over b. And that's showing that the slope is that. All right, I'm going to stop here and let you go ahead and try some of the problems on your own. All right, take care.